A tower of Hanoi means it is simply a puzzle or a mathematical puzzle that uses exactly three rods or three pegs, in some other words, and any number of discs, means n number of discs you can use. And the main objective of this puzzle is to move the all the discs or an entire stack of discs from source rod to destination rod using a auxiliary rod. So the simple rules for tower of Hanoi is the one at a time you can move only one disc, means you can't move more than two discs or three discs at a time. You means you have to move only one disc at a time. And the second rule is the higher disc should not be placed over the smaller disc, means you can't keep a smaller disc over the larger disc. That is the second rule. And third rule is you can't move the bottom disc before a top disc, means the only topmost disc should be moved. And the third is here the spelt wrong here. All discs should be moved to destination rod from the source rod within the moves of 2 power n minus 1 without exceeding that. Means if you have 3 discs, that is 2 power n means 2 power 3, that is equal to 8. So 8 minus 1 is within 7 moves you have to move all the discs. You can see for all the n values. For one disc, that is 2 power 1, which is equal to 2. 2 minus 1 is within one move. You have to move the disc from A to C rod. If the n value or discs is 2, it takes 3 moves, because 2 power 2 is 4. 4 minus 1 is, it takes 3 moves to completely move the disc from A rod to C rod. So if the disc's value is 3, if the discs are 3, it takes 2 power 3, that is equal to 8. 8 minus 1 is 7 moves it exactly takes. And this continues, this so on. If the n value is 4, 2 power 4, which is equal to 16 minus 1, 15 moves, and this continues. So mainly let us see the program, how it works. So the program is very simple here. So first using Python we are writing the program here. So first writing the function for the tower of Hanoi. The keyword def tower of Hanoi is the def function name, and we are having 3 parameters here. One is n, that is indicates number of discs. A is, so this is the main analogy which you are not finding in any YouTube channels. So this is what, see, first we are checking n value. Here n is not equal to 0, right? We are asking n is equal to 0, as 3 is not equal to 0, because we have passed 3 discs. So you can see here n is equal to 3, which is not equal to 0. So this function, this condition will not become true. Directly it comes to this recursion statements. So this is represented here left side, and print statement is represented in middle, and last statement is representing here. So n value is 3 initially. So first n value is 3. ABC means 1, 2, 3 discs. So now what happens is this statement recursion is taking place. So n is 3. 3 minus 1 is 2. So here we are passing parameter as ACB, because A to B using C as an auxiliary. So A means what here? A is 1, C means 3, and B means 2. This is the recursion of ACB statement. And then printing A to C. A is what? 1, C is 3. So printing A 1 to 3, moving disk from first rod to third rod. And third statement again, recursion of this statement again takes place. So again here also the n value is 3 itself still, because for this function to take place, this is the main function. So 3 minus 1 is 2. This time BAC, sorry, BAC. B means what? We can see here B is 2 and A is 1 and C is 3. And for the further recursion to takes place, this is not to consider as a main function. Now you have to consider this as a main function. So see, this becomes a function for these two recursions to takes place now. So now tower of Hanoi function is again called here. So now observe, this time ACB again I am calling n minus 1. N is now is not a 3. Here the n value is 2. So n minus 1 becomes 1. So now again trying to call a function ACB. So ACB, but now we are passing parameters to A, B, C. Here also this is A, B, C. You compare these here. So now, so ACB I am calling again. So ACB means what? Here you can check. So here ACB means who is the ACB? So A is 1, C is 2 and B is 3. So it becomes 1, 2, 3. Okay. So here you can check what is the print statement. 1, 2, 2. I am moving a disk from first rod to second rod. That will be printed here, because as you can see A to C, source to destination. Who is staying here in source and destination? Here 1 is the source and 2 is the destination. Moving disk from 1 to 2 here. And again right side for this function to takes place. Again here tower of Hanoi recursion is again calling. So n is 2 here. So n minus 1 is 1. So BAC, B means who is here in the middle? B is 3, A means 1 and C is 2 here. So you have to write C clearly. Okay. So this is completed. So again we have to move towards the right side of this tree. So again here 2 is still the n value. Again this recursion takes place. Again the three statements are getting to executed. See here again n value is 2. So n value is 2 means n minus 1 is 1, and this time ACB means who is ACB? So A is 2, C means 3 and B is 1. Again print statement is going to execute in the second. So print statement, source to destination. Source is 2, moving a disk from second rod to third rod. That will be happening here. Okay. Next, this right side is done by tower of Hanoi, this statement, third statement in the program. So again calling the same function. Again for this recursion also the n value is 2 itself. So now you can see 2 minus 1 is 1, but BAC means B, who is staying in the B position? 1. So 1, A is in the 2, so 2, and C is in the third position. So 1, 2, 3 will be the new parameters. So again for these things again recursion is need to happen, but this time the value of n is 1 here. You can see here. So 1 means 1 minus 1, because tower of Hanoi again going to recursion. 1 minus 1 is what happens? 1 minus 1 becomes 0. So when it goes to the main function, again here 0 you are passing. So when n value is becomes 0, what is happening here? So n is equal to 0, this statement becomes true, it returns. It won't allow again to recursion to takes place or to these statements to execute. So this will not be executed, but these print statements are executed. So again here you can see 1, 2, 3. So here recursion not takes place, but print statement, as per print statement, what happens here? One disk is moved from A peg to third peg, that is 1, 2, 3. Here also 1 is there, recursion not takes place because 1 minus 1 is 0. Here also 1 minus 1 is 0, it won't take, but print statement executed. So here the print statement is moving a disk 1 from 3 to 2, that is C to B. Here also 1 minus 1 recursion not takes place, but printing disk from moving disk from second peg, that is B to A, or rod 2 to rod 1. Here also recursion not takes place, XX, that's why I have written. But print statement, as per print statement, disk is move one disk from 1 to 3, that is rod 1 to rod 3, or rod A to rod C. So that is what here is happening. So here, that's what the steps you can observe. This is first, this is second, this is third, this is fourth, and this is fifth, this is sixth, and this will be the seventh. That's what is happening. You can observe here. Here you can observe what you have. Here you can observe in the step 1. See here, 1 2 3. Here in move 1, rod 1 is moved from A to C. So you can observe A to C. 1 means rod 1, A to C. That's what here, A to C. In the second move, see here, 1 to 2. From second will be 1 to second B. So A to B. So that is, you can write here A to B or 1 to 2. Here you can see in the move 3, what is happening is C to B. Move 3, move 1, move 2, move 3. C to B, that is C means 3 to 2, that is C to B. Don't get confused with numbers and alphabets. So C to B means that is third, C to B. 3 to 2, that is C to B. That is the third move. In the fourth move, you can observe first to third rod. In the fourth move, you can see first to third rod, that is A to C. That is what, A to C, or 1 to 3. So from one rod to third rod, that is move 4. Okay, in move 5, 2 to 1, that is B to 1. So you can observe here B to A. Here it is there actually. From B to A we are moving. So B to A. B to A. That is move 5. In move 6, so what we have to do is, this should be moved here from rod 2 to rod 3, or B to C. B to C. That's what it came here. B to C. In the move 6, B to C, or rod 2 to rod 3. So rod 2 to rod 3 we are moving this second disk over this. This is the move 6, and the final move you are getting output here 1 2 3, or A to C. So here is one disk that is left here, that we should move to here from rod A to rod C. So that is what 1 2 3, or A to C. So this is what the final output for tower of Hanoi. How this the best way to analyze this algorithm is by drawing this tree diagram. This will be the best method. Okay, thank you. Got the doubt that, sir, what happens if the disks are 0? So simply, if the disks are 0, so n is equal to 0. So 0 is equal to 0 means it returns, this becomes true, and it won't allow these statements to happen here, because 0 means here itself it become true. It won't execute the tower of Hanoi, because for 0 disk you need not to move anything. Okay, next, if in case of 1, n is equal to 1, disks are 1 disk is there. So what happens in that case? So n is equal to 1 means 1 is not equal to 0. Yes, this will not be true, and it goes to this statement. So in this statement what happens is, n is equal to 1. So 1 means what? 1 minus 1 is 0. 1 minus 1 is 0. 0 is again this tower of Hanoi recursion is calling this function. So 0, n becomes 0, so n 0 becomes 0 is equal to 0 means again it returns this statement. This recursion doesn't, first time it executes, but after first time what returns happening. So return means this print statement is going to execute. That is, only one disk is there, just move that disk. For example, here you can observe, here only one disk is, assume that one disk is there, that is only one disk. This is rod 1, this is rod 2, this is rod 3. So what you have to do is one directly move that A to C disk, need not of any auxiliary node. This is not recursion takes place. So simply this statement executes, that is move disk 1 from rod A to C in the single step. This executed. So what happens if the disks are 2? So if the disks are 2, this recursion takes place twice, because n becomes 2 here. So 2 means 2 minus 1 1. So 1 is true, the recursion takes place. So if the disks are 2 as you asked, see 2 means 2 is not equal to 0, if statement becomes true, and n minus 1 means 2 minus 1 one time recursion takes place, ACB. So what happens is within 3 moves all the disks are moved here, that you can observe here. Within 3 moves means, so 2 disks are there initially. So first one disk, that is disk 1, which is moved from A to C rod. So here you can observe 1 to B rod, the first disk is moved, that is smallest one. In the second move what happens, this second disk is moved from A to C directly. A to second move is directly moved to this here. So now 2 disks are moved, and only thing that is left is here one smallest disk, that one needs to be kept over this. That is happening in the third move here. So one is finally moved from B rod to C, or second rod to third rod, that is one is kept over the 2. So in this way, if the disks are 2, it takes 2 power 2, that is 4 minus 1 is, within 4 moves all the disks are moved from source to destination with using auxiliary B node. So I hope you understood. If any doubts, please post me in comment. Don't get confused. The steps actually happening, not, this is not the beginning statement which is going to execute. Actually, as the recursion takes place, you might know that. So n minus 1 means 3 minus 1 2, it won't print anything at this moment. So again this recursion takes place, again n minus 1, 2 minus 1 is 1, here also it won't print anything. So when you are trying to do 1 minus 1 again recursively, 1 minus 1 means 0. So when n becomes 0, this is the first statement which is going to print. This is not the print statement which is going to print first. Don't get confused with this. Actually this is the first statement which is printing, and this is return statement. So because 1 minus 1 is 0, it will return to here. So here again this is the second move, and this is the third move, and this is the fourth, and this is the fifth, sixth, and this is the last move, that is A to C, or rod 1 to rod 3. So as you can observe, recursion means this is recursively happening. So until it becomes 0, it won't return, it is keep on going this side. 3 minus 1 is 2, 2 again calls the function, 2 minus 1 is 1, so again 1 minus 1 is 0, so 0, then when it becomes 0 here, n is equal to become 0, then it returns back here. So then the first statement here it prints. Okay, so in this way this is happening. This is the first move, first print, second move, third move, fourth, fifth, sixth, and this is the last. See, so don't as I said you before, so how actually the sequentially the steps are happening. As I said, right, this is the first print statement which is happening. See, you can see from rod 1 or rod A to rod C, or 1 2 3. So that is what the first statement which is getting printed here. So move disk, that is 1, So 1 you can observe here 1. So 1 move disk 1 from rod. See here, from rod we have read from rod A. So A, so 1 2 3, that is A to C. So A to C. So in this way all the steps you can check here. In the second move here 1 to 2 means that is A to B. So A to B. In the third move you can see third print statement 3 to 2, that is C to B. C to B. In the fourth move, this is fourth move, so that is A to C, that is A to C, that is third disk, because here the disk is 3. So disk 3 is moving from A to C. In the fourth move, see here 2 to 1, that is B to 1, B to A, B to 1, B to A, B to A. So that is disk 1, that is disk 1. Here you can see, so here 2 to 3, that is B to C, B to C, sixth move, and the disk is second one. So disk 2 is moved from B to C, and the last one is, so that is 1, disk 1 from A to C, that is 1 2 3, that is A to C. In this way the disks are moved. These are the analytical part of this program, and these three statements, how this recursively takes place. Thank you once again.